All right, let's get right into it. If you're a cloud architect, you know the struggle I'm talking about, trying to tame the absolute chaos of multi-cloud security. Today, we're going to talk about how to forge a single, unified firewall strategy out of all that complexity. So let me ask you this. Are your cloud firewalls speaking different languages? Yeah, that probably hits a little too close to home, right? If you're trying to juggle security across AWS, Azure, and Google Cloud, you know exactly what I mean. It feels less like you're an architect and more like you're some kind of overworked translator at the UN just trying to get your security policies to understand each other. Okay, so let's put a name to this problem. We're going to call it the multi-cloud firewall chaos, and that's exactly what it is. A daily battle to keep one single, consistent security posture across a bunch of different platforms that, let's be honest, were never really built to play nice together. And this right here, this table just lays the problem out so clearly. You've got AWS with its security groups, Azure with its network security groups, and GCP with VPC firewall rules. I mean, they kind of sound the same, but they work in completely different ways. Just look at the scope. One's at the instance level, one's at the subnet, another's for the whole network. Even the basic rules, like allow versus allow and deny, are different. This isn't just a simple translation issue. This is a straight-up recipe for disaster, for misconfigurations, and for leaving huge security holes you might not even know about. So what happens? Well, all this inconsistency forces you to that manual imperative box on the left. You're clicking around in 3 different consoles, typing in commands for each cloud provider one by one. It's so slow, it's begging for a typo to bring everything down, and keeping it all consistent, forget about it. What we really want is to live on the right side of this slide. We want an automated, declarative system that's reliable, it's fast, and it makes consistency the default, not the exception. So, how do we actually get there? The first step is to stop fighting these little fires everywhere. It's time to build something bigger, a unified framework. We need to create a system that brings order to this chaos, one that puts all our multi-cloud security under one single point of control. And I love this quote because it gets to the heart of the matter. This is the big mental shift you have to make. The goal is not to get better at managing 3 separate firewalls. The goal is to manage one security policy, and then have that one policy deployed everywhere. It's about defining your intent once and then letting automation do the hard work of translating it for each cloud. Okay, so how do we make that happen? It all starts with the very first pillar of our new framework, the blueprint. And our blueprint is going to be declarative code. This becomes our one and only source of truth for every single firewall rule we have. Now, declarative can sound like a jargony word, but it's really simple. It just means you describe what you want, not how to do it. You literally write down in a file what the perfect end state looks like. This port is open to this IP address, for example. Then you let your automation worry about the how to make that happen in AWS, how to do it in Azure, and how to do it in GCP. This code becomes your master blueprint for security. And once you start treating your firewall rules like code, you get all these amazing benefits that developers have been using for years. Suddenly, everything is version controlled in Git, so you have a perfect time-stamped history of every single change. It becomes super easy to audit, which makes your compliance team happy. And best of all, it's reusable. You can create standard security patterns and apply them again and again across different projects, knowing they're right every time. Okay, so having that master blueprint is huge, but it's not enough on its own. A blueprint is useless if people are just ignoring it and building whatever they want. That's why you need a guardian, a system that's constantly watching to make sure your live environment perfectly matches that blueprint. This brings us to our second pillar, detecting drift. So what is drift? It's the enemy here. Drift is any change that happens outside your nice, clean, automated process. You know, it's that manual rule someone adds in a panic at 2 a.m. to fix something. Or even worse, it's a change made by someone who shouldn't be in there at all. Drift detection is like your 24/7 security patrol. It never sleeps. It's always scanning your live firewalls and checking them against your code, your source of truth. And here's why that's so important. Drift detection gives you one thing, certainty. It tells you instantly when an unauthorized or out-of-process change happens. It guarantees that the policies you spent all that time crafting are actually the ones being enforced. And for security and compliance, that kind of certainty is everything. It's absolutely non-negotiable. All right, so we've got our blueprint, the code. We've got our guardian, drift detection. The last piece of this puzzle is the gatekeeper. This is all about having a rock-solid, auditable process for approving every change before it ever goes live.
This is where we bring smart human oversight into our automated world. The best way to think about it is like air traffic control for your network. No plane takes off without clearance, right? Same idea here. No new firewall rule gets deployed until it's been properly reviewed, checked out, and signed off on by another human being, usually through something like a pull request. And this gatekeeper process is what saves you from those nightmare scenarios. It forces a peer review, meaning you always have a second set of eyes on a change, catching potential mistakes. It creates this perfect audit trail so you know exactly who approved what and when they did it. All of this just massively reduces the risk of some accidental misconfiguration taking down your app, or even worse, opening up a security hole. So there you have it, our 3 pillars: the blueprint, the guardian, and the gatekeeper. Now let's put it all together and see what the system actually looks like in action, from start to finish. So here's the workflow. Let's say an engineer needs to open a port. Step 1, they don't log into a console. They define that new rule in code. Step 2, they submit that change for a peer review and get it approved. Step 3, as soon as it's approved, automation takes over. It deploys that rule, perfectly translated, to AWS, Azure, and GCP. And finally, Step 4, the whole time, our drift detection is running in the background, constantly making sure that what's live in the cloud is exactly what's in the code. It's a beautiful, clean, secure, closed loop. So what's the big payoff? Why go through all this? Well, the results are, honestly, transformative. First, you get way better security because you have total consistency and control. Second, you get a huge boost in operational efficiency because you're automating a process that used to be a massive manual pain. And third, you get this rock-solid, easy-to-prove compliance posture that's going to make your next audit an absolute breeze. But, when you really think about it, this framework is so much bigger than just firewalls. It's really a new way of thinking about how to run things in a multi-cloud world. Because once you've used this model, this blueprint, guardian, and gatekeeper to solve your firewall chaos, you're going to start seeing all the other chaotic places you could apply it. So I'll leave you with this question. Once your firewalls are finally unified, what are you going to automate next?